Well, section 2.2 talked about linear functions and decided if something was linear based off of how you could write it, and used intercepts to graph lines. Now we're going to talk about rate of change and slope. And so we want to be able to calculate the rate of change and use that to determine the slope of the line. So when we talk about things change, it is important to describe it in terms of blank the change took, of how long. So, for example, if I said that I grew 3 feet, it would make a big difference if I grew 3 feet over the weekend versus 3 feet over 10 years. And so how long something took makes a big difference. So I might say that a person makes $1 million as a teacher. This seems really impressive until I tell you that it takes, let's say, maybe 30 years to make that kind of money. And so the rate of change would ask us to divide. So I do $1 million divided by 30, and that'll give me how quickly they're making that money. So in this case, it's really $333,333.33 per year. That seems like a much more reasonable annual salary. Right? So again, it's important when you talk about rate of change to talk about how long that change took to take place. Down here we talk about the different ways that we refer to slope. So when we talk about slope, we use the variable m, and if you remember from Algebra 1, that's talking about the rise over the run. And that rise over run is the change in y. So this little triangle symbol is the Greek letter delta, and it represents change. So I would read this as change in y over change in x, or y2 minus y1 over x2 minus x1. So how quickly does one variable change in terms of another variable? That's our job. And so when we talk about a positive rate of change, the graph will go up and to the right. It is increasing as we read the graph from left to right. Both variables are increasing, or it's possible that both variables are decreasing depending on which direction you read the line. So for example, if I read it from left to right, both things are going up, but if I read it from right to left, both things are going down. Negative rate of change is the opposite here. It's going down and to the left, and one variable is increasing while the other is decreasing. So for example, a good example of negative rate of change is that my bank account goes down as the amount I'm spending goes up, right? That makes sense. So that would be a negative rate of change. Let's flip over to the back. On the back here, we've also got this idea of zero rate of change. A zero rate of change is a horizontal line. Okay? And this is also known as a constant function. One variable is constant while the other one goes up and down. Right? So no matter what happens, over time, we are always here at 2 in this example. Okay? For finding slope, like we do in the next several examples, you're going to use 2 points and you're going to use the equation from the front. And so if you remember that equation, it's the change in y, so y2 minus y1 over x2 minus x1. And so what I do typically is I mark my points. I've got x1, y1, x2, and y2. And that helps me get the right numbers in the right spot. So in this case, I've got 4 minus 3 over, so I took my y2 minus my y1, 4 minus 2, which is x2 minus x1. And then just work it out. 4 minus 3 is 1, 4 minus 2 is 2. And so my slope is 1/2. There are several of these that you can do on your own, but let's skip to number 3, please. So number 3, I'm going to mark my information again. x1, y1, x2, y2. And I'm going to say 15 minus 20 over negative 18 minus negative 18. Well, anytime I have minus a negative, I can change it to adding a positive. And so 15 minus 20 is negative 5. And negative 18 plus 18 is 0. You cannot divide a number by 0, so in this case you would say that your slope is undefined. This happens because the 2 points here violate the vertical line test. This is not a function. You cannot draw that line. So it would actually be a vertical line through x equals negative 18. Okay? I'd like you to do numbers 2 and 4 on your own, and then feel free to check your answers with the information online. But in the meantime, we want to take a look at number 5. So for example number 5, it says, in 2004, there were 56,878 students who applied to UCLA. I should think of that as an ordered pair. So I'm actually going to put parentheses around it. This is an ordered pair. Then in 2006, the applicants jumped to 60,291. So we want to find the rate of change. So this is my x1, y1, x2, and y2. So in order to do slope from a word problem, we need to kind of put things into a rate of into an ordered pair. So my y2 is 60,291 minus my y1 is 56,878 all over 2006 minus 2004. So I'm going to go to my calculator here. I've got 60,291 minus 56,878 for a difference of 3,413 students over the course of 2 years. So if I take that answer and divide it by 2, I get that they actually increased by 1,706.5 students per year. The numerator of my slope was talking about the number of students who applied. The denominator was years, so that gives me my students per year. Last example here on this packet is to find the rate of change from the table. They give us the time and the distance. This will be my x, and this will be my y. Now, if this is linear, it doesn't matter which 2 points I pick. So I'm going to pick this one and this one. It doesn't matter. You can pick whichever points you prefer. This is going to be my x1, y1, x2, y2. So to do my rate of change, I'm going to do 56 minus 16 over 14 minus 4. y2 minus y1 over x2 minus x1. 56 minus 16 gives me 40, and 14 minus 4 gives me 10. And when I divide, I get 4. So then I have to go back. This would be 4 minutes. I'm sorry, my y was in the numerator. 4 feet per minute in the denominator. So when my y values are in the numerator, that should come first when I talk about the label, and then my denominator label will come second. So we've got 4 feet per minute is our answer. Again, don't forget to go back and do examples 2 and 4 on your own, and then you're welcome to check your answers on the assignments calendar on the class website here.